Hey there fellow learners, welcome back to another chapter in our Unity tutorial series. I'm your host Cherry, and today we're diving into how to create 2D movement, aka how does velocity work in Unity. Before we jump into today's tutorial, a quick reminder for those who might be new to our journey. If you're unsure about the Addon Assets we're using to organize things in Unity, I highly recommend going back to the first video in the series. These assets are not only free but also incredibly useful, providing a solid foundation for our workflow, and I will be using them in this video. Now let's dive into the tutorial. Before we get into the video, I made a bet with my friend that I will be able to reach 1000 subscribers by the end of the year, so I need your help to do it. If you could just subscribe to the channel, it would help me out a ton, so thanks in advance and let's get into the video. First of all, to implement any kind of movement, you will need the Unity input system. You can install it by going into the package manager, scrolling under I, and you simply need to press install in the top right corner, and then after restarting Unity, you should be all set to go. Now that we have the input system installed, I'm gonna select our player character, and now when I scroll down to add component, I will have player input available. I will need to create actions, which will be our key bindings. I'm gonna save them in settings presets. I'm gonna overwrite my old one, which I did when preparing for this video. After that's done, you should get a pop-up window like this one, and as you see, the move action is a vector 2, aka 2D coordinate matrix. Now you need to just add another action, which will be jump. I will assign space to it. There we go, and select keyboard and mouse as the input type. I'm gonna just save this real quick and close it. And now it's all saved. Now, when I set the player input's behavior to be invoke Unity event, an events tab should open. Now when I open it, I should be able to open the player category, and as you see, inside of it there's my move and jump callback. I'm gonna create new ones for this, which I will assign different actions to later. And then I'm gonna open my scripts folder and create a player controller script. I'm gonna overwrite my old one, which I created while preparing for the video. And now when I assign the script to the player, we can start coding. I'm gonna open my IDE and delete the start and update functions so we can start from 0. The first things we need to do is we need to create two variables, a private float speed and a private float jump power. As you might think, they will indicate the speed of the player and the height of the jump. The serialized field prefix means that they will be available in the inspector to actually edit them inside of Unity, but they will still be private, so no other script can reference them by accident. To make the player move, we will need to assign velocity to it. To assign velocity, we need the rigid body component, which manages the physics. So I'm gonna create ourselves a private rigid body 2D RB variable. To actually assign the rigid body variable, I'm gonna go create a void awake, which will be activated whenever the script starts, and I will assign RB equals getComponent rigid body 2D. GetComponent gets the highlighted component of the object it's assigned to. In this case, it gets from the player the rigid body. Now we need an action that will be referenced to the player input component. I'm going to create a public void which will be called onMove. It's public because we need a different script to use it. Inside of the public void onMove, I'm going to reference the input action.callback context, and I'm going to name it context. The context in this case is basically all of the information that we will get from the input, aka which direction we will be trying to move, W, A, S, and D. And since the jump function is separate, we only need the horizontal move input. So I'm going to create a private float horizontal move input, and I'm gonna set it by default to be 0. Now that I have it, I can actually get the horizontal move input from the context. I'm gonna test horizontal move input equals context dot get read value vector 2, because that's the type of the context, and I'm gonna add dot x, which is the x variable, which is horizontal. But now we actually need to do something with that variable, so I'm gonna create a private void fixed update, which is called every physics frame, unlike update, which is called every visual frame. And that's the reason that you should use fixed update for anything related to physics, movement, or anything that cannot be delayed with the actual visual delay. Inside of the fixed update, I'm going to do rb.velocity, which is the velocity of the object, and I'm gonna set it to new vector 2, which is gonna allow us to play around a bit with a new value. We do not need to edit the y value, aka the vertical, so I'm just gonna set it to rb.velocity.y, which is just setting it back to itself. Now to change the horizontal, I am just simply going to do horizontal move input, which will be the direction, and I'm gonna multiply it by speed. That allows us to actually give the object velocity in the correct direction to our movement. By the way, there is a huge sale going on the Unity Asset Store right now where all of the OMAP Studio assets are 50% off. You can also claim a free asset pack just by clicking Get Your Gift and entering a coupon code inside of your checkout. If you want to buy anything, use my link from the description down below. It costs you nothing and it helps me out a ton. And now, let's get back to the video. Now I'm gonna go back to Unity and it will recompile real quick. After that's done, I'm gonna go back to our player and scroll down until we go back to our player input. I'm gonna open the events and get the move event, and I'm gonna assign the new event from our script to be the player controller on move. Now when I started, the player won't move, and that's because we did not set our speed variable inside of our script in the inspector. Now that we've fixed that, it's all better now, and we can actually see the player move correctly and in the correct speed. Now, if your player will fall over like this, that's because you don't have the lock rotation Z set inside of your rigid body 2D inside of the player game object. You simply need to set the lock rotation on Z to be true, and then it's all fixed. But this platformer would be very boring if all we had was the horizontal movement. I'm gonna go back to our IDE and I'm gonna create a new void which will be on jump with the same input action, callback context. And now I'm going to create an if statement for if context.performed. This function will be called if context is performed, cancelled, or is held, so I'm just gonna check if it's actually performed, aka clicked. Now if that's the thing, I'm going to need to change our velocity again. Again, we do not need to change our horizontal velocity, so I'm gonna just reassign it back to itself. And for the vertical velocity, I'm simply going to add our jump speed. But now, we want our jump to be, well, variable in length. So for example, I hold longer and it's gonna jump higher, I hold shorter, it's gonna jump, well, not as high. To do this, we need to cut our jump when we stop actually performing the action, so context.cancelled. If that happens, we need to set our velocity again. We don't want to change the horizontal velocity, so it's going to be back to new vector to rb.velocity.x, and the second thing will be rbd.velocity, which is the current velocity, and we will actually make it, well, weaker, which by cutting it in half by multiplying it by 0.5. That will simply decrease our velocity while we are jumping, so we can actually, well, start falling. Now, after a quick recompilation, we will need to actually assign the new jump thing to our player in the same way we assigned the movement. So let's assign it to player controller on jump, and now let's press play. And as you see, the player is actually able to jump. And as you see, it's variable in height, but look, I can actually hack walls and I can somehow actually climb them, which is something that we do not actually want. Now the fix to this is very simple. It's all because of friction. All we need to do is remove friction from the tile map. To do it, we will need to create a new physical material inside of our materials folder. I'm going to create a new material called frictionless, and as you might have guessed, I'm simply going to set its friction to 0 and assign it inside of our tile map, and let's go frictionless. Now when I press play again, as you see, the player is now going to slide off of walls, but I can actually stand there, and that's because it's the edge of the tile map. Each tile has its edge, and sometimes your player can actually get locked by it. To fix this, we need to make the tile map a composite collider. A composite collider basically combines all of your colliders that touch each other into one giant one. Doing this is actually very simple. All we need to do is actually add the composite collider to our tile map and then select use by composite. Here I forgot to actually set the rigid body that also gets added to static, which means that it will not fall, and it kind of fell, but you simply need to set it to static and it will work. Now the problem we're going to run into is that the player can just jump as much as they want no matter what, which means that they will be able to, well, go to space. To fix this, we need to check if the player is actively on ground. To do this, let's start by adding a new layer, which will be the ground layer, and we need to assign our tile map to it. I already have done that, but you can also do that by just selecting layers and pressing add layer and just naming it by your own way. We need to do that to check if the player's collider is actually colliding with the right thing and, for example, not with a second collider connected to itself. Now that we've done that, we can go back to our IDE and start coding. In my opinion, the best way to check if something is grounded is to create a boxcast. The boxcast is basically a box that's casted from the player that checks if it collides with anything. Let's create a private bool is grounded function which will return true or false. And then we need to create a raycast hit 2D, which will be our boxcast. Let's name it raycast hit, and let's set it to be a physics 2D blood boxcast 2D, which is our boxcast. The boxcast function accepts a lot of different parameters. The first one it needs is an actual box collider 2D. So let's actually create a private box collider 2D collider or call. We will assign it from the inspector later. The first thing that the boxcast accepts is the origin, which is the center of our collider. Then we need our box collider size, which will be called .bounce.size. Next we need to give it an angle, which is the rotation. We will not have any rotation, so let's set it to 0f. One of the final parameters will be the direction, so let's set it to down vector2.down. And now we need a distance. This will be the length of the actual box collider, the length of the extension from the player. Let's create a new variable for that, and let's call it private float ground distance. And let's set it to 0.2 by default. After that, let's assign it back to our isGrounded function to raycast hit, and now we have our final parameter, which is the layer mask, which is the layer that it will be allowed to check. That's why we have created the ground layer, so it does not check any other collider other than that ground layer. Let's create a new private field, which will be the serialized field as usual, and let's name it private layer mask or ground layer. We'll be able to assign it in inspector to be the layer that we want, and let's assign it to our raycast. Now we need to make the isGrounded function return something, so let's return raycast_hit.collider is not equal to null. It's basically an if statement that checks if it collides with something. If it doesn't, it returns, well, false. If it does, returns true. The null basically means if the collider is not nothing, well, return true. Now that we have a functional check if it collides with the ground layer, we will be able to actually assign it back to our jump function. Now we'll check if context.performed and is grounded. And now it will basically work perfectly fine. Now what we'll need to do now is to actually assign the box collider to the player. We need to create a new box collider for it, and what I like to do for it is to actually just scale it down to be a little tiny thing near its feet, and then we can just assign this into our player controller, and there we go. It works perfectly fine now. We have a functional jump script. So yeah, hope I helped. If you enjoyed, subscribe, or all of the different things that YouTubers tell you to do now. See you in the next one. Bye!